Okay, so for this class, we have two chapters to cover. Both very easy. Again, every class I feel like I say the same thing, but because it's the truth. Um, but let's see, the first chapter is about exponents, yeah? Powers and radicals, actually, not exponents. So an exponent is part of the powers and radicals chapter, and an exponent is when you have, for example, something to the power of something. So 5 to the power of 4 is power of 4 means that you have 5 multiplied by 5 4 times, right? So an exponent has some basic rules that everybody should know. We have them listed here. So x to the power of 0 always equals 1. And then you have the second one, x to the power of a multiplied by x to the power of b equals x to the power of a plus b. And this is only the case when both both x's are the same, obviously. And then you have if x of x to the power of a is divided by x to the power of b, x to the power of b equals a minus b. Is the difference is when it's multiplied, it's the exponents are added, and then when they're divided, the exponents are subtracted. And then when you have that x to the power of a to the whole thing to the power of b, this means that the power is a times b, right? So x to the power of a times b. When you have x to the power of negative a certain number, or in this case, the negative a, then it is the same as saying 1 over x to the power of a without the negative sign. And if we have x multiplied by y, so here we have two different numbers, but both of them are multiplied by have the same power, then the power is distributed to the two. So we get x to the power of a multiplied by y to the power of a. And then we have if x is to the power of a fraction, so a to the over b, then that means we can write it in this way. So the denominator is the power of the radical, and the numerator is the power of the x, the number that you have. So in this case, it's going to be x of a under the square root, not square, yeah, square root of b. I guess in this case, it's not the square root, it's the radical of b. Um, and then if we have the square root of a to the power of b, then the square root is divided by the top and the bottom. So square root of a over the square root of b. And the last one is if you have the square root of a multiplied by b, then also the square root can be distributed over a and b. So we have square root of a multiplied by the square root of b. This should be like very easy. You should know all of these just in case in the SAT you get a question that requires you to use these basic rules. So an example would be here. Use the rules of exponents to find the following. Yeah. So we have x to the power of 2 multiplied by x to the power of b equals x to the power of 9. In this case, he's asking for b, right? So using the properties or the rules that we just mentioned, we can write x to the power of 2 multiplied by x to the power of b as x to the power of 2 plus b, which equals the x to the power of 9, right? And in this case, because the x's are the same, we can immediately conclude that 2 plus b equals 9. So we have this, and then we solve for b, we get that b equals 7. This way we solve the first one. Please stop me if you have any questions or you want me to repeat if you want me to repeat anything. The second one says that we have 2 to the power of 3, the whole thing to the power of b equals 64. Again, we need to find b. We know that 64 is, we can write it as 2 to the power of 3 to the power of something. Yeah, so because we know that 2 to the power of 3 is 8, right? And 64, we can write it as 64 is the 2 to the power of 6. And in this case, it means that that 3b here equals 6, because one of the exponents rules is that if you have this kind of thing, then 3 is multiplied by b, right? So 3 multiplied by b equals 6. This means 3b equals 6. When you solve for b, you get that b equals 2. And then you have this. In this case, we only just need to rewrite it so to practice the rules. We don't really need to solve for anything. This is just an example to make you familiar, like make you feel familiar with the concept or the rules. You have this term divided by this term. In this case, we know that if we have 3 a's in the top and then 10 a's in the bottom, that leaves us with 7 a's in the bottom. So a to the power of 7, in this case, it becomes like 1 to the power of a to the power of 7. So you can write 1 over a to the power of 7 as a negative 7, or you can just immediately write, like leave it in the denominator. And then b to the power of 7 over b to the power of 8, that leaves you with 1b in the bottom, like here. And then c to the power 11 and over c to the power of 6, this leaves you with 5 c's at the top. Is this clear? These are just two different ways of writing the same thing. Again, if you wanna like check this, go back to the exponent rules, and then you're gonna see that they're exactly the same. The next one says that 3 to the power of negative a equals 81. Then what is a? We know that 3 to the power of 4 equals 81. Then immediately we can check that if if the power of 3 equals 4, then in this case negative a equals 4, which means that a equals to minus 4. I hope this makes sense. And then we have that x to the power of 3 over 2 equals 8, then x is what? In this case, because we have an exponent, a power that is a fraction, then what we can do to cancel it from one side and add it to the other side to find x, we multiply it by I'm not sure what it's called in English. When you flip the top and the bottom of the fraction. So if you have 3 over 2, then you multiply it by 2 over 3, because we know when we multiply these two fractions, you get a 1, right? So in this case, and of course, if you multiply, if you take the power of 2 over 3, or any power in general, you have to take it on the other side as well. That's why we have a to the power of 2 over 3, right? And then we get that x equals 8 to the power of 2 over 3. You can do it like immediately in the calculator, or you can rewrite it. Rewrite this one, but I guess you can just do it immediately in the calculator, and then you're going to find that x equals 4. And obviously you can check by substituting the variables that you found into the original equation. And then we have radical, like simplifying radicals and stuff. Again, also goes in the exponent rules, the basic ones. You can check them to verify. But this concept is very easy too. If you have 4 to the power of square root of 50 minus 3 to the times the square root of 32, we know that 50 can be written as 25 times 2. 32 can be written as 16 times 2. The whole point of this is to make solving the radical easier. And in this way, we know that both 25 and 16, you can find them, like they're very easy radicals. So because of the exponent rules, we know that we can distribute the radical over 25 and 2, so we get 4 times the radical of 25 times the radical of 2, in the same case here. And then we know the radical of 25 is 5, and this stays the same because there is a radical of 22, but it's not a complete square. And then we have that the radical of 16 is 4. And so multiplying 4 times 5, we get 20 radicals of 2 and minus 12 radicals of 2. This means that doing the algebra here, so 20 minus 12, you get 8 radicals of 2. Is this clear?
Yes.
Okay, good. And then you have the same concept here. You have 9 9 multiplied by the square root of 24 divided by 2 to the multiplied by the square root of 27. Rewrite 24 and 27 under the radical to make it easier. So we get 4 times 6, and then on the top, and then in the bottom 9 times 3. This way we can distribute the radical over 4 and 6 and 9 and 3. We get this expression here. And then we know the answer to the radical 4. We know the answer to radical 9, which is 2 and 3. We multiply the two numbers that are outside the radical. So 9 times 2, 18, 2 times 3, 6, multiplied by the radicals, the respective radicals. So we get this expression. And we immediately can just divide 18 by 6, which is 3. And then knowing the exponent rules, again, this one here, we can write the expression of radical 6 over radical 3, like 6 over 3 in under one radical. So 6 over 3 becomes 2. Yeah, so the whole answer, or the whole simplification of this term is 3 to the power 3 multiplied by radical 2. And then the last one, we have 7 multiplied by the radical of x plus 14 equals 42. Then what is x? Here is just like easy algebra. Again, we take plus 14 to the other side, it becomes negative 14. We get this expression. So 7 multiplied by radical x equals 28. After solving this part, and then divide by 7 on both sides to get this. Radical x equals 4, and then to get rid of the radical, we multiply by, or we take the power of 2 on both sides. So we get x equals 4 to the power of 2, which equals 16. That's okay? Good. Now, the last thing is we have an example from an actual SAT exam. We have this expression, and we need to find y. So we have 16y equals 2 to the power of 4 plus x. From the basic rules of exponents, we know that this expression can be divided into two, which are 2 to the power of 4 multiplied by 2 to the power of x. Because we need to find y, we divide both sides by 16. So we do that, and then we find that 2 to the power of 4 also equals 16. So 16 cancels with 16, and then we're left with y equals 2 to the power of x. So the answer is obviously A. Okay. That concludes our first chapter of today. Extremely easy. It's just like basic stuff based on the basic exponent rules. Please make sure you do the practice examples in the book, and at the back of there are practice examples at the back of every chapter, and then there are specific chapters with extra SAT problems. Chapter 8. Basic algebra. The first concept of doing basic algebra is simplifying polynomials. Is when you have two polynomials multiplied by each other, what do you do, and stuff like that. The basic concept of it is multiply each term in one polynomial to each term in the other polynomial, then add and subtract the similar terms. So in this case, for example, we have this polynomial multiplied by this. In order to solve it, we have to multiply each term by each term in the other polynomial. So in this case, we have to do 4x squared multiplied by x, which is 4x cubed, and then 4x squared again multiplied by 5, which is 20x squared. And then you do the same thing for the second term in the first polynomial, 5x multiplied by x, which is 5x squared, and then 5x multiplied by 5, which is 20x. And then you do the same thing for -3 multiplied by each term here. So you have -3 times x, and then -3 times 5, which is -15. You have to make sure that you take the sign of the number that you're taking. So it was positive here, it was positive here, and then it was negative here. So the negative is also multiplied with the number. And then the negative goes down. Make sure you use brackets because this affects your the next steps that to come. Okay, so after doing the multiplying the first two polynomials, we put them in one bracket, and then we put the negative sign. We do the same thing for the other two brackets, multiply them by each other, put them um, in one bracket. The reason why I'm telling you to use brackets is because in the next step, after combining the two terms, you have to distribute the negative sign into the next bracket, right? So let's add and subtract the similar terms first. In this case, we have only one x to the power of 3 term, so that term stays the same, and then we have two terms that have x to the power of 2, so that means that these two terms are similar, and so because it's plus 20 x to the power of 2 plus 5x to the power of 2, then we add them, we get 25x to the power of 2, and then the other two similar exponents are the ones with the x, so that means that it's 25 minus 3, which is 22x, and then negative 15 is the only one. So that stays, that is the step where you add and subtract the similar exponent for the first bracket. For the second bracket, we only have one similar term group. So we have negative 8x plus 7x, which is like negative x, and then the rest stays the same because they don't have any other similar terms. And then you get where we need to distribute the negative sign. So by distributing the negative sign, every other term in the following bracket changes signs. So because negative multiplied by positive here is negative, we get negative 2 to the power of negative 2x squared, and then negative multiplied by negative, we get positive x, and then negative multiplied by negative, we get positive 28. In this case here, in this step, you can remove all the brackets and then do the add and subtract, the addition and subtraction of similar terms again. When you do that, just like we did in every single bracket, we get this expression here, and this is the way, in this way you simplify the polynomials. Is this clear?
Yeah.
Okay. When it comes to factoring polynomials, we have to check if there's a common factor or number in all the terms that you have, and then you can check the answer by multiplying that common factor by the rest of the polynomial, and then another I guess like rule that you need to know is the difference of squares. When you have a to the power of a squared minus b squared, you can immediately just factor it as a minus b multiplied by a plus b. Okay, this is a general rule. Everybody uses it. It's just what it is, yeah. And you can check that this is true by multiplying these two polynomials to get a squared minus b squared. So how do we apply the factoring of polynomials and the difference of squares? Let's take this example, 3x squared minus 27. This has a common factor, which is 3, because you can divide both terms by 3. And when you do that, you get that, and if you take 3 as a common factor, so it's multiplied by, when you take 3 when you divide 3 on this term, you get only x squared, and then when you divide 3 by this, you divide the second term by 3, you get negative 9. Okay, and by using the difference of squares, because as you can see, this can be written, obviously this x squared minus 3, 9 is basically 3 squared. So it's exactly this. We can use the difference of squares to factor this out, and we get the x minus 3, x plus 3. And obviously the 3 comes down here too. Okay. In this example, we can write it as a quadratic form. So we take 7x to the other side with a negative sign, or the opposite sign. In this case, it's a negative. So we get x squared minus 7x plus plus 12 equals 0. We can factor this. You can use a calculator to factor, or you can just use basic concepts from high school. I guess the basic concept from high school, you need to find two numbers that when multiplied, you get this term, and when you add them, you get this term. So we get x minus 3 times x minus 4, which equals to 0. And when you solve it, you solve for x minus 3 equals 0 and for x minus 4 equals 0. And then you solve for x. In both cases, you get two answers, x equals 3 and x equals 4. To check, you substitute each x in the original quadratic formula to get a 0. If you get 0, then your answer is correct. And then you have another example, which is this form. Again, you need to write that in a quadratic form for you to actually factor it. So 25, you take it to the other side with an opposite sign. In this case, it's going to be a negative. So you get 2x squared minus 13x minus 20 minus 25. You have two terms that are the same, so you add them. So you get minus 20 minus 25, which is minus 45. And then you can factor. Again, the similar way of what we did here. You're going to have that 2x here and then an x here, and then you have to find two terms that when you multiply, you get negative 45, and when you add, you get negative 13. And the answer is 5 and negative 9. So you're going to have 2x plus 5, x minus 9, both equal 0, just like here. And then you solve for x, and then you find that x equals 9, and then x equals negative 5 over 2. Again, if you want to check, you substitute in the original formula to get a 0. And then we have the concept of solving inequalities. Are kind of different than solving normal equalities or normal formulas. Because when you add and divide, if you multiply or divide by a negative number, the inequality flips. You have to switch it. So an example here, we have negative 2x plus 9 is larger than or equals 15. In this case, you have to take plus 9 to the opposite side, and then you get minus 2x larger than or equals 15 minus 9. You obviously do this. This is 6, and so you get minus 2 over x larger than or equals 6. You divide by negative 2, but when you do divide by negative 2, you have to flip this inequality sign. So you get that x is less than or equals negative 3. And then when you draw it on the number, like on the in Arabic, we call it خط الأعداد. But when you draw it, it's like that. But I don't think you have to pay attention to the drawing. It's just like to visualize it better. But this is the answer, yeah. And then we have the concept of an absolute value. An absolute value is it's written like this, and it means that the the absolute value is always a positive number. If you have the absolute value of x equals 3, this means that x can be either 3 or negative 3, because either ways the outcome is a positive 3, right? Therefore, if you want to solve an absolute value, you have to take what's inside the absolute value and multiply it by a negative sign to solve. So once you take so you have to solve it for two things. Once when it's normal, when it's the same thing, and then once when it's multiplied by a negative sign. You're gonna understand more when we solve an example. We have this one, the absolute value of x minus 4 equals 6. Again, we have to do it two times. Once when it's exactly the same, x minus 4 equals 6, and the other time is when it's multiplied by a negative sign. So x minus 4 equals minus 6. And then you solve for x in both cases. For this case, you're going to find that x equals 10, and then for this case, you're going to find that x equals negative 2. Both answers are correct, and to check if they are correct, and just in case you're doubting yourself, you just put it in the in the original formula to check your answer to see if you're gonna get 6 or not. And then the second one, also in this case it uses an inequality, so they're combining two concepts with each other. So you have the absolute value of 2x plus 7 minus 6, which is not in the absolute value, larger than 11. In this case, before dealing with in the inequality, you take minus 6 to the other side, so it becomes plus 6. You get this expression, and then you'll have 2x plus 7 larger than 17. So again, now we have to deal with the absolute value. How do we deal with the absolute value? By doing two cases. The first one is by the way it is, just so 2x plus 7 larger than 17. And the second case, you'll have to add a negative sign to one side. And remember that when you add a negative sign, the inequality switches. So instead of having a larger than, we have a less than. Also the negative sign. So in this case, when you solve for x, you're going to have that x is larger than 5. And in this case, if you're going to solve for x, you're going to have that x is less than negative 12. And these both answers are correct. But when you have to check for your answers, obviously because you don't have an equality sign here, it's x less than minus 12. You're going to have to take numbers that are less than negative 12 to see if your answer is correct. The same case here, you have to take numbers that are larger than 5 to see if your answer is correct. Yeah, so that's on solving with absolute value and inequalities. And then we have solving systems of equations. That's the case when you have two equations and you need to solve them at the same time to find x and y. So we have an example, 2x plus 4y equals 10 and x minus 2y equals minus 3. Now, when you're solving equations simultaneously, you have two methods. The first method is the substitution method, and the second one is the elimination method. Now, which one is easier and which one you prefer is completely up to you. Honestly, I don't know which one I prefer. I think I prefer the elimination method because the substitution method is like a bit lengthier in my opinion. But let's look at both cases. When you're doing the substitution, you have to look at the equations and write one. So in this case, we'll look at the second equation, yeah, because we already have one term and it's easier to deal with in this case. We have to write this equation in terms of y. So we're gonna get taking negative 2y to the other side, we're going to have that x equals negative 3 plus 2y, okay? And then we take this expression and we substitute it in the first equation. So we're going to get 2 multiplied by x, which is negative 3 plus 2y, plus 4y equals 10. Okay, and then we distribute 2 in this bracket, and then we get this term. So negative 6 plus 4y plus 4y equals 10. Obviously, we have these two terms that are the same. And then we take negative 6 to the other side with the opposite sign. We get that 8y equals 16. Divide by 8 on both sides, you get that y equals 2. Now, we obviously have to continue to find x, right? And then we remember that we already wrote this expression in terms of y, and x immediately is going to be solved. So we substitute 2 in this expression to find x. We're going to get that x equals minus 3 plus 2 times 2, and then x is going to be 1. Okay? Now, we're gonna look at the other method using elimination. When you're doing using elimination, you're gonna have to look at the formula and to see what number you can multiply one of the equations to eliminate a certain term. In this case, because we know that we have 4y and it's a plus 4y, and we have a negative 2y, we know if we multiply this equation by 2, we're going to get negative 4y. In this case, when you add the two equations, the 4y and the negative 4y are going to disappear, are going to be eliminated, and you're going to be left out with the x only. This makes the process much easier, and this is exactly what we did here. We multiplied the second equation by 2. So we get this expression here. And then you solve these two formulas at the same time. You add the two equations. You get the 2x plus 2x, which is 4x, plus 4y minus 4y, which is 0. So these two terms are eliminated. And then 10 minus 6 is 4. And then you solve for x, you're going to find that x equals 1, which if you notice is exactly the same x that you found here, which is how it should be, right? And then to find y, you substitute x in one of the equations here. In this case, we did the first equation. You substitute x in the first equation to find y. Once you find y, you're gonna have 2, which is again exactly what we found in this case. Again, what method you prefer is up to you. Personally, I find this method easier to work with, but I hope this was easy to understand. If not, I can repeat it.
It's easy.
Okay, sorry?
It's easy.
It's easy. Okay, good. Okay, now we're at the end of this chapter. We have some SAT problems again. If we have x to the power of 2 minus 12 larger than 0, what are the possible values of x? In this case, we just need to solve the inequality. We take negative 16 to the other side, becomes 16. We take the radical of both sides to get rid of the square. We get that x is larger than square root of 16. The square root of 16, the answer of it is plus negative 4. You can find this also by adding it, putting it in the calculator. Always when you're solving a radical, the answer is always plus minus that number. So either x is larger than 4 or x is less than negative 4, because remember, when you have a negative, the inequality sign switches. So in this case, the answer is E. And then the second one says that if you have 2AB plus BA equals 4 and A equals a half, what is B? This is, I don't understand the point of this, because you can just substitute A equals half into this expression, and then you can just solve for B. But I guess in the book they did the solving simultaneous equation, which is, I guess, another method you can use, but this is just easier and quicker. So you just substitute A equals half in here, and then you solve for B. You're going to find that it's B plus 3 equals 4. Take plus 3 to the other side with a different sign. You're going to find that B equals 1, so the answer is A. Is that clear?
Yes.
Okay. This means that we're done for today's session. This is all I have for today. It sounds like a lot. Maybe it is a lot, but it's just a lot, but easy concepts. Because again, these are just like grade 9, I think, even less, grade 8 maybe. But if you have any questions, you can ask me now, or you can ask me in the next session. Yes, ask.
Can you open the factor in this chapter?
What about it?
I think here, yes. How we found x minus 3 and multiplied x minus 4.
In which example? Here?
Yes.
Okay, so you're asking about this part, right?
Yes.
How did we find? Okay. I'll teach you 2 ways. The first way is by guessing. When you guess, you're gonna have to guess like 2 numbers that when you multiply, you get this term, the term without the x. So minus 3 times minus 4 is 12. and then when you add them, or when you add these terms, you get the term with the x, which is -7. So -3 minus 4 is -7. There's another way using the calculator. I'm trying to find my calculator. There is a certain way of using your calculator. I don't know which calculator you have, but when you do mode 5, 3, and then you input the data you have. So it says A, B, C. I'm trying to, I don't know if I can show you. Wait, let me show you. Let me stop sharing and then start video. Can you see me? No. Okay, you can see me now, right? So I have this calculator. I don't know if you have the same one too. It's also annoying because you can't see it. Okay, but basically what you do is, do you have a calculator with you now?
No, no.
No. Okay, I can do it and send the picture to Hasmik, and then she can send it to you, hopefully. But what you do is shift or mode 5, 3, and then you're gonna get A, B, and C. When you get the A, B, and C, you just look at the formula you have. The term A is gonna be 1 here, so you enter 1 equals, and then B is gonna be -7, so you input -7 in your calculator, and then C is 12. So 12 here. You press equals, you're gonna find that x1 equals 4 and x2 equals 3, which is what we have here. Is this okay? Again, this is all by calculator, but if you want to do it by guessing, you can, again, just think of two numbers that when you multiply them, you get 12, and when you add, you get -7. The calculator method I'll send on WhatsApp, and then she can forward it to you on Facebook, okay? And then you can practice on your calculator. Other than that, do you have any other questions?
No, thank you.
Okay, you're welcome. I hope you're doing the exercises. If that's